Well, that's a fourth root, correct? 1/4 means the fourth root. Is t a perfect fourth? We don't know. Exactly. We can't come up with a single simple answer, so we just leave it like that. Okay? But if I had this, can I simplify this?
No, because it's not a perfect square.
9's not a perfect square?
Yeah, it is.
That's equal to 3. Okay? All right.
Okay, so if it's just a normal exponent, we do times itself however many times. But if it's a fraction exponent, we do the radical. Basically. Okay, never mind.
Yes. Okay.
Thank you.
All right, now, don't write this down, just think it.
I always think.
If fractional exponents are another way of writing radicals, and we cannot have a radical in the denominator of a fraction, do you think we can have a fractional exponent in the denominator of a fraction? No, because it's the same rules. They're the same thing, so they have the same rules, okay? Shh. Let's come back here real quick. When we had a radical in the denominator of a fraction, we know how to handle it, don't we? So if fractional exponents are the same as radicals, wouldn't we handle this the same way? We handle it the exact same way. This is the sum. So we multiply the numerator and denominator by y to the 5/2 minus 2. You handle it the same way as if it was a radical, because it is the same thing as a radical. All right? Which means now we have to go back to what's the laws of exponents when you're multiplying. Okay? All that other commotion.
How did that?
I'm coming. Hold on. Just like if this was a square root of y plus 2, we would multiply by the square root of y minus 2. Since this is essentially the same as a radical, we handle it the same way. All right? Let's see if I have this.
So what the answer was?
Okay, I don't. All right, hold on a second.
Just scroll down.
We're going to take this fraction, and in order to remove the fractional exponent in the denominator, we're going to multiply it by y to the 5/2 minus 2. But whatever I do to the denominator, I have to do to the numerator to keep the fraction having the same value. All right, well now let's look at the numerator. How do we take this and multiply it to that distribution? Okay? The top is just distribution. Okay, we're going to multiply y times y. What's the rule for the exponents?
You add them.
Add them, okay? So it's y to the 3/2 plus 5/2, which would be y to the 4th. Very good. Austin, Lex, Tyson, whoever else. Hush. You mean it? Y to the 3/2 times -2. Is a -2, y to the 3/2. In the denominator, remember the whole purpose for doing this is because when we do FOIL, the inner and outer terms become 0. So all we need to focus on is first times first in which we add the exponents.
Wait, Miss Sam, the first one.
Yeah. Why do you get
On the
Jacob.
top, why would it be? See how it's got the exponents on top, like on the side. What? It's 2y, so it would be y squared plus the 2 exponents.
No. If it was y squared, this would be 1 and 1. Okay? No. This is the exponent. There's no imaginary exponent there.
When you
Okay.
do y times y, don't put the square.
Wait, why'd you do?
It's the exponent plus the exponent.
I know, but what I was saying is the 2y.
That's when all you see is a y, because you're adding 1 plus 1. Because the exponent is 1. But now it has an actual different exponent.
Why do you get 2y?
Because I multiplied y with an exponent to 2. Okay, whether the exponent's a fraction, a radical, or a cow, it's 2 times y to that exponent. All right, and then our outer and inner terms are going to disappear. So last times last gives me -4. Well, this is all I have to do to figure this out. Simplify this. What is 5 halves plus 5 halves?
Oh, 10 halves. 5. Yeah.
And that's your answer. Now, I had someone in the last class ask, well,
No, wait,
yesterday, ask me this. Stop talking.
Can you repeat how you did 5? So we got 5.
Okay, repeat how I did 5. First times first,
And those 2 going.
we add the exponents. 5 halves plus 5 halves is 10 halves. And 10 over 2 is 5.
And I see my get this.
All right, now somebody in the first hour class said, can you just cross out these y's? No, because recall from before the break, this is a family. Remember? It's a group. And unless there's an exact group just like it, then nothing cancels. All right? And here, this is a group. And unless something exactly like it is at the top, then no, nothing cancels.
The exponent has to have a base.
An exponent has to have a base. Exactly. All right. That's what you're going to be working on tomorrow, but I want us to look at some examples real quick.
So we have no homework tonight?
Right.
Thank you, Jesus.
Now, we looked at how do you get this fractional exponent out of the denominator when it's part of an addition or subtraction problem. Let's talk about when it's just by itself. Now, remember, when we had a radical, we said if it's a cubed root, that means we need 3 to take it out, correct? All right? When it's a fractional exponent, we need this fraction to become a whole number. So we need to add some fraction to 1/2 that turns it into a whole number.
Negative 1/2.
No, positive 1/2.
Oh,
Okay? So I need to multiply by this specifically because 1/2 plus 1/2 is 1. But if I multiply in the denominator, then guess what?
You do it in the numerator.
I got to do it in the numerator. All right? So now I have 2x to the 1/2 over x to the first power. You cannot cancel those x's because it's just like a radical, and you cannot have radicals in the denominator. And right there, you've got a radical in the denominator. Okay? And you can't do anything else with it because if you try to fix it, you're just going to end up right back where you started, and you'll have a fractional exponent in the denominator. All right? Now that was easy, but we multiplied by the same thing.